Okay, hope everybody's back. Yeah, really good. So you you just go in a lot of times you just have a single multiple choice problem. You go ahead, assign a number, and then yeah, that would be the right answer. But also we have a general way to do it. I just put M7 as seventh grader, M8 as eighth grader, and immediately we have M8 equals 1.5 M7. And then we just need to add 0.06 M8 plus 0.03 M7. That is just everything become M7, right? And then we got 0.12. 0.12 M7 divided by total. Remember, total is M7 plus 1.5 M7, so that's 2.5 M7. And then cancel the M7, that's 4.8%. And again, assign a number, make it easy to calculate, and you figure that the number actually doesn't matter in this case. It's just a ratio that matters. Okay, so really good. Thanks, Yoshi. Let's do one more. Okay, I just need an equation. Anyone? Anyone can give me an equation? We don't want to spend too much time in this.
So if it's a profit of 20%, that means they're getting in price of, they're added 25% off. They're getting a price of 1.2 times 6.25, which is 7.5. So they're selling it at $7.5 at 25% off sale. And then we can multiply that by, well, we can find out that they priced the toy at $10 because 75% of, so
yeah, you don't need the final answer, but that's really good. So you just put basically you're saying 75%, that's 1 minus 25% times k equals 6.25 times 1 plus 20%. So this is the profit, and you get k equals to 10. Okay, very nice. So Avnish, this is Avnish, right?
Yeah.
Which group are you?
5.
5. Okay, thank you. Thank you. This is pretty straightforward, and I think I'm gonna skip this. I want to quickly introduce the permutation and combination. We started to see them in the homework, and it's very important. So permutation is basically how many choices to arrange a group of elements from a possibly bigger group. The order of elements in each arrangement matters. One example is if we have 9 students are given 7 different chairs, how many ways to sit them, right? So we can just first pick 7 students out of 9, and then the order of them matters because it means who will sit on which chair, right? This is a permutation problem. And another example is you pick a fruit from apple, pear, peach. They're all different fruit, right? You give 1 fruit to each of the 3 students, and 3 students are different. And how many choices to distribute the fruits, right? Same thing. We first pick 3 fruits, and then we make the arrangements. So, and the order of the fruits matters because it means who will get what fruit. So in general, we have this permutation as P and K. That's you pick K out of N and made arrangement. And that's equals to N factorial over N minus K factorial, okay? One case when P and n, you pick n out of n, that's basically n factorial, okay? In the first example, we know we can do P97, right? We pick 7 chairs and then we arrange them. So this will give us 9876 until 1 divided by 2. So it's basically 9 times 8 until 3, okay? And the second problem, we pick 3 fruits from 4, and we make arrangement. So that P43, that's 4 times 3 times 2. Okay. Hopefully this is a review. Okay, it's not the first time you are introduced to this. And for combination, everything is the same except the order of elements in each arrangement does not matter. And the example would be 7 identical teddy bears are to be given to 9 students. Assuming each student can only get 1 teddy bear, how many ways are there, right? So just this is a problem of select 7 students out of 9 that can be given a teddy bear. Once it's select, you don't have to arrange them anymore because everyone just get a same teddy bear, okay? And in this case, it's C97. So we use combination. So C97, we pick 7 out of 9. And the order doesn't matter. Second example, softball team needs 9 players. How many of choices to form a team from 12? Okay. This is just to form a team. It doesn't matter who does what position. So we just select 9 players out of 12. The order does not matter within a team. Okay. So in this case, the example would be C12, 9, and the expression of formula would be C and K equals n factorial divided by k factorial, and then divided by n minus k factorial. Okay. So if you compare with P, we added k factorial in here, okay, right here, okay. So if you look at C97, it basically the whole thing divided by 7 and then divided by 2. So basically 9 times 8 divided by 2, okay. Actually, is that right? 9 times 8 divided by 2, yes, 36. All right. C and n equals to 1. Why is that? From definition, you pick n elements out of n elements. There's only 1 choice, right? You pick all of them. Okay, when you do the calculation about C97, you'll find that you don't do 9 times 8 all the way down. Instead, you do C92 because C and K is equal to C and n minus K. So this is a property, okay? Why? Because when you think about C62, you pick 2 elements out of 6. It's the same of C64 because every time you pick 2, the rest will be 4. So that's the same number of arrangement when you pick 2 or 4, okay? So when you do C97, you will just do C92. Same thing when you do C12, 9, just do C12, 3. Make sense? Any question? Okay, now let's do a quick problem here. Should be 1 minute. Okay, anyone?
So if Anne of Von Leah is a book, there's already one fixed one. So we only have 2 more to choose from the remaining 7. So basically it's P72.
P72 is how many ways you can choose 2 books from 7.
Yeah. And then you have to, since it's
Order.
ordered pair, you still have to include the Anne of Von Leah thing. So you multiply by 3 factorial.
Yep, that's correct. Yep. So basically, that's right. So you basically pick 2 out of 7. You already have 1. You pick 2 out of 7. Once you have them, you will do a full arrangement. You do a P33, right? This 3 is gonna do basically 3 factorial. They can be the order can be random. All right, so we don't need to calculate this. Just write down the expression. That should be fine. All right, so this I don't know if I want to. Okay, let's do this problem, and that will be our last one for today. Okay, what is the P? P means probability. Okay, what is probability? Again, just show me your thought. Oh, actually, I already have it in here. Yeah, maybe that means I'll just go over it. Okay.
Wait, but how many cards are drawn at a single time?
5.
5 right here. Yeah.
Oh, okay. Oh, yeah.
Yeah. So it's asking what's the probability that a 5-card hand contains exactly 2 aces when choosing from 1 deck of cards. And this is, just a probability thing, right? You just pick 5 randomly. What will be the 2 aces? So what we know is a deck of cards has 13 values, and each value has 4 colors. Okay. Now the first thing we want to do is 2 aces. There will be 4 different colors, and we pick 2 out of 4. So that's the 2 colors of ace. This is how many ace you can pick, right? Now once you picked ace, you're gonna have the rest of 3 cards. What can that be, right? So the rest of the 3 cards should be, you already picked the 2 from the 52, right? You have 50 left, but that 50 left, you have 2 aces, right? It says you can't have any more than 2 aces. So those 52, you have to minus 2. Sorry, 50 minus 2, so that's 48. So you basically calculate how many of the 3 cards can be taken out of 48. So this will form the 5 cards with exactly 2 aces. And it's asking you the probability. Therefore, this is how many choices you have. You have to divide it by the total choices, which is pick 5 from 52, right? That's the total choices of holding 5 cards. And this is the total choices of exactly 2 aces. And yeah, do you have any question for this problem? Okay, if not, you're free to leave. And for people that still want to join the group, please send me email, and I want to know what's been holding up your